Here we go. Hey guys, hope everything's going well for you today. It's a little cloudy and gross out, but other than that, I think we're all going to survive. So today's lesson is going to be pretty simple. We've now learned how to solve elimination or solve systems using graphing, which would be if they were both in slope-intercept form. So that would be like y equals 3x plus 7, and the other equation would be like y equals 2x plus 7. And those equations is where we're really focused on. Do they have the same slope? Do they have the same y-intercept? And what does that mean? So if it was the same slope, same y-intercept, you'd have infinite solutions. If it was same slope, different y-intercept, you'd have no solutions because they're parallel. And if it was different slopes, it didn't matter what the y-intercept was. They're going to cross, which means you have one solution. The other way we looked at was solving by substitution. And we would always use that method if you had one that was in standard form and you had one that was in slope-intercept form. And you would just plug that slope-intercept form into the y of the standard form equation, solve, and you would get it. And last but not least, we had solving by elimination. So today we're literally just practicing identifying what solution I should be using to solve. And to do that, we're just going to have a time decline that pops up and drills a bunch of, look at these two equations, which method should I use? And you have to just select the right method. So there's really no work for you to show today in class, outside of the 3 practice problems at the end, which I'll be putting a tutorial to by 4 o'clock today. So with that being said, let's go ahead and just dive into it. So we're just going to break down each method we're using, so the graphing method, the substitution method, and the elimination method. So when we have graphing, if this is the main method to use, is our graphing method, it's very specific, okay? We need to have 2 equations that are in our slope-intercept form. So like this. That's what slope-intercept form looks like. And if they're both in slope-intercept form, so they both say y equals something, graphing is the way you're going to want to solve that. Okay, and what will happen is you'll graph and you'll look for where they intersect, and that's your solution. So that's when we use the graphing methods, if they're both in this slope-intercept form. Okay. The next method, my marker doesn't want to cooperate with me today. The next method we looked at was our elimination. Okay. Actually, this was the 3rd one we looked at, but since I already wrote it on the board, we're going to just run with it. I'm going to switch markers because I'm not liking the way this one's working. In the elimination method, the way we would solve that is if both were in standard form. So we're going to say both standard, which means both equations look like this. Okay, and all we're doing is we're looking for a way to eliminate one of these values, so they both have to be in standard form. That's the key if you're going to use the elimination method. They both need to be in standard form. So 5x plus 3y equals 7. X and y are on the same side. They equal something. That's a standard form equation. Again, both x and y are on the same side. They equal something. That's a good way to see your standard form equations. If they're both in standard form, the way you're going to want to solve that is with elimination. Okay? And last but not least, the second one we covered, and the one we worked on the most in class together before this great quarantine, was our substitution. Substitution. Okay, and our substitution was if you had one in standard and one in slope-intercept form. Okay? And what that looked like on paper would be like 3x plus 7y equals 20 and y equals 9x plus 5. If we had those 2 equations, this is my slope-intercept equation because it's y equals something times x plus something. So this format, and then the standard format's up here. If we had those 2, we would just take our slope-intercept format and we would plug it into that. And that's where that substitution happens, and that's why we're always looking for standard and slope-intercept ones to solve with our substitution. Okay, so that's all you're doing today is you're looking through example problems, identifying which method would be the most effective to use. At the end of that, I do have, and I'll solve one of these for you real quick, but I do have like a 6x minus 6y equals 0, and then 3x plus y equals negative 12. I have 3 of these types of problems for you to solve, just to practice the elimination since we're just finishing up with that this week. So to solve this, what I'm going to do is I'm going to look at, for a term to eliminate, I'm going to pick on my x's here, because I know if I times this entire bottom equation by negative 2, that'll make a negative 6x, which will be the opposite of a positive 6x, so I know those will cancel. So I'm going to distribute everything that in, so I'm going to have negative 6x minus 2y, and negative 2 times negative 12 is a positive 24. I'm going to move this equation back down below, just like that. That's going to eliminate, so now I'm going to combine. Okay? Negative 2 minus 6y is negative 8y equals 24. Divide both sides by negative 8. That goes away. And I'm left with y is equal to negative 3. Okay? So if I wanted to start my parentheses, I'd be like this. And then all I'm going to do is take this negative 3, plug it back into one of my initial equations. 6x minus 6 parentheses negative 3 equals 0. 6x, negative 3 times negative 6 is a positive 18 equals 0. Minus 18 from both sides. Now I have 6x equals negative 18. I'm going to divide both sides by 6. And I get x is equal to negative 3. So x equals negative 3. Y equals negative 3. And as a coordinate set, it would look like negative 3, negative 3. Okay? Again, I will have a tutorial up by about 4 o'clock today, depending on how my afternoon goes, which shows those 3 problems that I asked you to do in the Nearpod to finish. At the very end, after your lesson was done, it says you're done for today. Then I posted the great trilogy challenge on Kahoot. I posted a high score for you guys. I doubt you'll be able to beat it, but hey, you know, dream big, guys. See if you can take down Robbie when it comes to movie trivia. I don't even think the Lunar Grapefruit can play with that, but I have a feeling Isaac Bodden's going to be made for this one. So iBod, hopefully you can nail it out. Or I have a whole slew of students that would be great. Anna in second period would probably rock this one. Claire, Mackenzie. I don't know. There's so many people that would take this one down. But hopefully if you're avid trilogy readers and watchers this time, you'll nail this one. But it's optional. Have fun with it. Try to take down my high score. Guys, have a great day. Tomorrow is just the practice quiz. You'll dive into that and get after it. But the practice quiz tomorrow will be very similar to the quiz. I will actually have about 7 to 8 of the problems from the practice quiz will actually be on the quiz. So I do encourage you to take it. Thank you. Have a great day and stay out of the rain. Woo!